Good afternoon. So I would say that my bio's in the back and you can learn more about me, but I think we missed the deadline, right, Mabel? So my name is Dr. Christine Grant. I'm on the faculty at North Carolina State University in Chemical and Biomolecular Engineering. I'm also an Associate Dean in Faculty Development and Special Initiatives in the College of Engineering. So I'd like to start here and now, right? We're talking about planning for the future and the road ahead for academia. So let's talk about this journey and this roadmap that we need to be on. And I wanted to mention before I got too far into my talk that we do have the North Carolina Space Grant that is actually located at the NC State campus. And the funny thing is, when I was on my way here from Raleigh yesterday, I ran into my colleague who actually runs that program, who had just come from this meeting. So that was really very interesting. But that program is actually working with a number of institutions across the state of North Carolina in terms of scholarships and developing research infrastructure. We also work with some historically minority institutions, North Carolina Central, North Carolina A&T, Winston-Salem State, University of North Carolina at Pembroke, and Elizabeth City State University. So if you're interested, I can give you some more information, or I can get you in touch with the person who's over that program. So as we get started, I wanted to ask a question. How many of you have an iPod? iPad, iPhone, right? I know we've all been using them today, right? So when we think about the iPod and the iPad, I was the one who got up earlier and mentioned that I had a 15-year-old. And we talk about the technology and how we use the technology. You know, we are users of technology, and I think our students are not as interested in learning about where that technology comes from. And so there have been some changes in how things are done. And the iPod, according to a reference I'm going to show you in a minute, exemplifies the changes in the success that are based in STEM, in the diverse foundation of STEM technologies. But the value add in the case of the iPod products comes from Apple's creative marketing and business innovations in response to consumer demand. And it's produced in a global market for an increasingly global consumer. So that's a little bit different than what we're used to. So we can say that the role that STEM workers play in innovation is rapidly changing. Actually, after this meeting, I'm going to a meeting in Arlington tomorrow for PASMIM awardees, previous PASMIM awardees, and I was reading a report on the way up here on the plane, so I actually incorporated a number of the quotes into this presentation last night. And so it says, in the past, we had the government that was heavily investing in R&D, and a small cadre of elite scientists made important discoveries, mostly related to national security and weaponry. This has been superseded by a much more complex innovation process that's tied to the global economy. So there are changes that have happened along the way, and I don't know that we've all adapted to how we actually do business. So in this report, it was really interesting because they were talking about the debate between whether we have too few STEM professionals or too many. Some of you know the report Rising Above the Gathering Storm, and there are different factions that think that we have too many people in STEM, and there are some who say, well, there's not enough, there's going to be a shortage. So my question is, what are the students hearing and what are they listening to? So too many versus too few, what's a smart student to do? Who are they listening to and who is right? Well, I'm not going to attempt to answer that question today, but I think that the messages that are going out in terms of the media and where people are getting their information will influence in the future where people are in STEM and who wants to actually go into STEM. So in this context, the boundaries between STEM occupations and the broader process of innovation actually become a little bit blurred. So what's really happening? Are there too many jobs or are there too many potential employees? The disagreement between those who argue STEM workers are undersupplied or oversupplied can be resolved by the fact that we know that there are a number of people in STEM, and we heard it from some of the speakers earlier today, who have talent or degrees that are diverted away from STEM careers in school and later in their careers. So this report goes on to say, one former linear conception of the relationship between science and innovation needs to be replaced by an interactive, dynamic network understanding that emphasizes learning and how students learn. So I just really like this report. So they were talking about the fact that if you look at the number of students who enter college who are getting ready to go for a STEM degree and actually obtain a BA, the number of students who graduate with a BA in STEM it goes from 100 down to 19. And then those who actually work in STEM careers after college, it goes down to 10. And then after 10 years, how many are working in STEM? It's 8. Okay, now you can parcel up the data any way you want to. Actually, in engineering, the numbers are a little bit higher. But I would say that a lot of STEM talent gets diverted into other occupations because students and people who are working in STEM may be perceived not to be satisfied in the STEM field, and the breadth of work that they're asked to do and the way they're asked to do it, as we heard earlier with technology, may not be exactly what they're interested in doing. So when I look at my friends and I see some of my friends who are not in academia, so who didn't go on to get a PhD, what happened to them? Well, I have friends who are in biomedical engineering. One of them, she's teaching law school. Another chemical engineer is working at a nonprofit. Another IE that I know, industrial engineer, is a judge. Another EE I know, my husband, is a business consultant in renewable energy, got an MBA. So if I look just at engineering, there have been a lot of changes and people have been going into different fields. And I'm talking about people who are not going on for a PhD to become professors. In addition, there are a lot of trends that are going on. There are policy shifts in how we spend our money, job losses in defense with the close of a number of different arenas. We've heard about that earlier. Tech layoffs, however, in Silicon Valley seem to be decreasing. And then we've got this issue of the foreign versus the domestic workforce, and we're not finding workers in the right skill set, we've been told. So now let's look a little bit more closely at engineering, because that's actually what I know best. So in the 21st century, there have been a lot of reports that have looked at engineering. The issues have been studied and reported. Organizations are leading in making changes and setting priorities and developing initiatives in this realm. So the National Academy of Engineering, an honorific organization that a lot of us are familiar with, set forward this thing called the Grand Challenges. The Grand Challenges in engineering are what are guiding a lot of the engineering development and a lot of the programs that are coming out of universities at this point. So this is one of my dean's slides, and he talks about the first thing we need to do is to make a sustainable world. So each one of these bullets or each one of these points is a grand challenge in engineering. The second thing we need to do is we need to make sure we're healthy, and if we're healthy, the next thing we need to do is make sure we're secure, and if we're secure, then we need to be able to enjoy life. So this is how the engineering grand challenges are set up, and I'm sure in different disciplines there are other challenges. So we need to be able to capture the key aspects of life, things that are interesting to students, to engage them and engage the future STEM workers. So if we look at the numbers, again, this report I was reading, and some of you may have some other references, it says that the STEM need in the workforce is projected to grow at 17% rate through 2018. So this table represents the educational distribution of job growth due to new and replacement STEM jobs in 2018. Now this table is actually much bigger. They break it out by computer and bio and all these other health-related fields. But if you see, it looks like we've got a lot of people that need to be educated, and you'll see that the majority of them are in the bachelor's arena. Okay, so if you didn't finish high school, well, you're not going to be able to get a job in STEM, generally speaking. And if you got a PhD, you could probably teach, but the majority of the folks, and do other research too, I'm sorry. But the majority of the folks are in the bachelor's degree. So where is the university? The role of the university is to innovatively create, inspire, and engage the next generation of STEM professionals to serve in traditional STEM and non-STEM roles to ensure a global economy. That's my statement. Okay, so that's what I think the role of the university is at this particular junction. So in the College of Engineering at NC State, we have a strategic vision that actually connects with the engineering grand challenges and around the things that we do in the college that are not really related to the silos of engineering, civil, chemical, mechanical, electrical. And so we can look at things like bioengineering, engineering health systems, security and critical infrastructure, and you'll see that these look like the engineering grand challenges, but that's what we've put together. So, of course, I couldn't get up here without saying something about NC State, right? So, NC State is a very large institution. In engineering, we have 6,000 undergraduates in engineering in our college. We have 2,500 graduate students. We've awarded a number of degrees. In terms of diversity, we are third in BS degrees awarded to African American students outside of HBCUs, the 13th in BS degrees awarded to women, the 8th in the number of African American tenure track faculty, et cetera, okay? So I don't have all the percentages here, but this gives you some information. In my role as Associate Dean of Faculty Development and Special Initiatives, my role is to work with the faculty, all faculty in the College of Engineering, to help them be more successful in their pursuits of getting funding. We take trips up to NSF. I bring speakers in, things like that. And this is a position that the Dean and I created about 4 years ago to do this. So we have about 260 tenure and tenure track faculty in our college, and you can see some of the accolades of those faculty. We have a number of career awardees. So we are, obviously, we've talked about this, a research-intensive institution. However, in order for us, and here are the different degrees that we have, the standard ones, and then we have some other ones: biomedical engineering, nuclear engineering, biological and agricultural engineering. So you'll see that we still have the silos set up, but when we try to do research and educational programs, we try to go across departments. So where are we going in the future? Our undergraduate enrollment is up about almost 7%. Our MS enrollment is up 47% because we have an engineering online program where students can get their whole master's degree online and never set foot on our campus. And our PhD enrollment is up about 20%. But I think that the thing that we need to talk about is vision. Nothing is going to happen unless there is some vision. So my dean, in my opinion, is very visionary. Some of you may know him, Dean Louis Martin Vega, who is himself originally from Puerto Rico and was at the National Science Foundation as the AD of Engineering for some years. He's done a lot of different things. I've put up some of his awards up there on the chart. So what are we doing in diversity in the College of Engineering, since we're talking about those kind of issues? We actually have 4 presidential awardees in our college. We have received the Presidential Mentoring Award from NSF for 3 individuals. I received it 1 year, and then for the minority programs that we have in the College of Engineering. So we actually held a meeting on our campus where we had 9 NSF Presidential Awardees for Excellence in Science, Math, and Engineering Mentoring come together and have a panel to talk about mentoring diverse groups of people. We have a minority engineering program where we have programs for the minority engineering freshmen, mentoring programs for them. We have a summer transition program for these students where they come up for 7, 8, 9 weeks and live on campus. You probably are familiar with these types of programs, but I thought I would put some of them up there. We have programs for women also. I didn't list all of them. We also have a Purpose Institute for Minority Faculty Development, which is an institute that I've developed a few years back to try to encourage and highlight the number of underrepresented minority faculty in engineering. We had an advanced grant, which is just coming to an end, in which we were able to touch over 110 minority women engineering faculty. Yes, there are that many around the country. So we had a series of summits over the last 5 years. Okay, so the last couple of things I want to tell you are that none of this happens without investment. So you need funding to do this, or you need to be innovative and creative in the ways that you do this. So we've been able to actually, this is under our present dean, hire a number of faculty. We've hired a number of women faculty. We have our first woman department head in engineering, in biomedical engineering. We also have a number of interdisciplinary initiatives that kind of cross these silos of departments and disciplines. And then the other thing that we have, which is also very attractive to students, is what we call this Engineering Entrepreneurs Program, where students come in and they can get training on business while they're doing their engineering. And so they have some activities and some really innovative things going on. Being at the university enables you to do a lot of very unique things with very little resources. In my role, I've been able to develop this thing called the Biomed Connect Mentoring Incubator. It's new, and I'm trying to get students to come through, be mentored, work with folks in biomedical engineering, because I'm in chemical engineering also, and relate to previous students who have come through programs and folks who they can look to being mentored by. So having a course about mentoring, how to manage mentoring relationships, going out to other places and doing internships or working in somebody else's lab through an RAU you probably know about all of these different programs. But my point is this, at a university, you can pretty quickly, if you can get the funding or even seed funding, do some of these programs because we have the infrastructures in place to work with students. Okay, so I'll just end by saying that we cannot win the future without a competent STEM workforce, but we need to understand the well-being of our workforce, our prosperity, and our nation depends on initiating these discussions, asking the right questions, and then finding the right answers. And I think that this forum has been a great opportunity to start to do that. I think that we need to think outside the box and set up relationships one-on-one and come together and work together in these arenas. So my last statement is the key to a robust global workforce is to engage and eventually utilize all of our human capital in the solution of complex problems using STEM principles and training. Thank you.
Good afternoon, and thank you for being here. As I guess it's almost 4:30. We're about to get our lunch or dinner, whatever. This is Aslan Chaudhary. I'm a professor and chairman of Mechanical Engineering Department at the University of Texas at El Paso. I also direct the UTEP Center for Space Exploration and Technology Research, which is a NASA University Research Center. And thank you again for inviting me. I'll take a different route today. What I really like to show that some of the emerging challenge for us in academia, and what should we do, and what should be a path forward to address those issues. This is a very interesting time for our country. We're coming out of a recession. Federal government is trying to tackle the deficit. Agencies are cutting budgets. States are reducing their funding. So it is a very, very interesting time for our higher education. With all those things, maybe there are some opportunities inside. So the first few slides, I'll try to show what are the emerging challenges. Our science and engineering workforce are aging. 46% of our science and engineering workforce will retire within the next 5 years, and there is a shifting demographics. But the most challenging thing is the part of the population which is growing has a lower educational attainment rate. So this is an emerging challenge, and Hispanics are almost 20% of, more than 20% of the population aged between 18 and 23. But their share of the BS degree in engineering is less than 8%. And if you look among all the engineering disciplines, what you can really see that in every engineering disciplines, minority students are seriously underrepresented. And it's not proportional to their percent in the total population. This is an emerging problem, and it's gonna continue to be amplified. I've been in University of Texas, El Paso over the last 11 years. First as a tenure track assistant professor, and then researcher, finally an administrator. So I had the opportunity to work with a lot of underrepresented minority students. And what I really like to share you, my experience working with them, and maybe that will highlight a way forward. If you look at that, most of the minority students who are really pursuing their higher education, they are not really choosing engineering as their first choice. The left slide is the top professions African American students they pursue, and the right one is the top 10 career the Hispanic students pursue, and very, very few engineering. So the population is growing. So if I try to summarize it, I'll try to summarize later, but I will try to talk about another new issues. Okay, if you recall that when US moved from this agriculture-based economy to technology-based economy, we created all the land-grant universities. And those universities allowed us to move from predominantly a agricultural-based society to a technology-based society. But things have changed actually. Those land-grant universities are predominantly located on the smaller areas to allow to people to pursue. But there is a rapid urbanization. Now 85% of all jobs are actually located in metropolitan areas. 75% of our nation's GDP come from 100 US metropolitan areas. So that means things are actually moving more in urban areas. Simultaneously, those flagship universities we created 100 years ago, they are running their full capacity and they are no longer creating access. So they accept 5 to 10% of high school graduates. So these new urban institutions, okay, and I'll give you some examples, are now required to fulfill this role of these large flagship universities. You know, the motto was, when we created these land-grant universities, is education for common people, right? That was the main theme of creating land-grant universities. But after 100 years, these land-grant universities, because of federal R&D dollars, become research behemoth, and they are closing their doors for most common people. So they no longer fulfill the role of education for common people. Rather, these urban universities are actually educating a large number of people. And this is my favorite slide. I'll always give an example of the universities. You can look at these urban universities, their enrollment is continuously growing. University of Texas at El Paso, Florida International Universities. One other thing you can also notice, these universities are actually educating those minorities. Most of these universities are top producers of black engineers, top producers of Hispanic engineers, and they are also top producers and Hispanic doctoral graduates. So these universities are actually the land-grant universities for 21st centuries. So if I try to summarize the issues associated with our academia facing, I usually tend to summarize in 3 points, okay? One is our changing demographics. With the changing demographics, the 2 issues are actually emerging. One is lower educational and attainment for those group of people who are growing. The second one is rapid urbanization. Because of cultural and other issues, people tend to live in cities now. And I know about Hispanic students, they don't really want to move out from El Paso. They wanted to go because they have a higher family ties or other economic situation. They like to stay where they are. Florida International University also, or Cal State LA, they all have the similar, the students wants to stay there. So if you create opportunities on those universities, usually it serves more people. And the second is a declining state and federal investment. Okay, over the last 10, 15 years, continuously, actually, federal investment and state investment is declining. What it's doing to us is that we'll keep raising tuition. Because university around, right, that make these things really unaffordable. Higher education, to me, is a civil right issue for the 21st century. So, by making this higher education unaffordable, because of rising tuition, and now there is also talk about cutting the Pell Grants and other financial incentives, we are making higher education only for a few people. And not only that, the second thing also is that we have this tendency to distinguish between 2 types of universities. Some are good and very good, but they are very selective. And there are other universities whose job should be only to produce, only to teach. The problem is, if you look at this larger university, they create excellence. So that means you are denying excellence to people. Okay, so that's another problem with the budget cut. And the last issues I think is more important is that globalization and also the rise of the emerging nations. What it is doing to us is, there was a time when you had a shortage of engineers who used to go China and India raid and brought 75,000 H1 visa. And right, those days are actually over, because those emerging nations have more jobs than us, and will no longer be able to access those talents. So there is a war on talent now in the world, and that war on talent is creating a war on innovation. So the globalization, so we have this trifold of problems: our declining budget, our problem with our changing demographics and associated problem, and also this globalization and emerging and rise of other nations. It's gonna just strain our higher education. So what can we do? Okay, so again, I'm gonna try to summarize 3 points. We have to make sure that we have access to engineering education and careers. We need to ensure that. We need to inspire. So all the programs we design, there has to be a component which can inspire the next generation of the student that that should pursue engineering or science career. I always give an example to my 7-year-old daughter. One day I asked her that what she want to be when she grow up. She said, because of Hannah Montana effect, and she said she want to be a model or a singer. So I told her that we're Asians and we don't give our kids any choice. You either pick dad's professions or mom's profession. My wife is a physician. So that's it. So maybe inspiration should have something that in it also, okay? And of course, we have to make sure that our higher education remain affordable and accessible to everybody. And then finally, creating excellence everywhere. We cannot no longer think that we only create 100 excellent university and leave other 200, especially those universities just listed behind, and assuming that they will provide excellence. So we have to have those. So what I read in my second point is that there has to be humongous capacity building and HBCUMIs. And that capacity building has to have a full breadth and capacity of a national research university. We tend to separate research and education, but they are not separate. They are the same thing. Research actually creates preeminence. Research actually creates opportunities. So research and education is not two different things. They are same in university environment. So this HBCUMI has to have the full capacity and breadth of a national research university. Of course, they also have to remember those universities that they cannot compromise their access to attain the excellence. There has to be joint attainment of access and excellence. And of course, we have not been changing our engineering education for a while. So this, because of globalization, now we are entering in a new age. There is a time engineer is to produce a product, we sell and we earn money. This age, and I picked the word from Alan Greenspan, many of you may not like him anyway, it's called engineering education for the conceptual age. Now we sell ideas. And we need to really prepare our students to meet those challenges of a conceptual age. Our engineering education needs to look like a professional practice-based education, more like a medical education, while you have a lot of practice involved in your engineering education. And of course, we have to make sure that our entrepreneurship and leadership skill, we nurture that from the very beginning. Just to give you some example of what I mean by these last topics, that professional practice-based education and research training, we have to integrate the most industry experience in all our academic levels. We have to incorporate professional experience in our PLOs, and we have to have an appropriate mix of teaching, research, and practice faculty. Practice faculties are those faculty who will bring the industry experience in academia. That should look like academia in 21st century. And of course, industry, like medical school, like the clinic actually take the ownership of the practice. So we have to have this industry ownership, and we have created similar facility at UTEP. And we have to create sites so our students can practice engineering before they graduate. Few weeks back, I was talking to a program manager, and he's telling me that they usually take 3 years before they can put in engineers in actual product development. Once they come out from the school, they are not really trained to do industry type of research or industry type of work. So we need to shorten those times if we really like to compete with other people. And of course, we have to ensure that we train our future engineers and engineering leaders in technology entrepreneurship and leadership. With that, I thank you everybody for listening to me. Thank you again.
Good afternoon, everybody. I'm Tim Olson from Salish Kootenai College. I'm chairman of our Division of Sciences at SKC, and I split my time between administrative work and teaching in physics and computer engineering. And what I'd like to talk with you about today is, from my perspective at a tribal college in a rural state, what I see the way forward is particularly in engaging with NASA to encourage students to go into STEM fields and on into STEM careers. So just a slide to kind of orient you where SKC is. We're in western Montana on the Flathead Indian Reservation. A very beautiful part of the country near Glacier National Park, north of Missoula, Montana. Just a few facts about SKC. We're a four-year college. We're a land-grant institution. We began in 1977. We're chartered by the Confederated Salish and Kootenai tribes. The Flathead Indian Reservation, that's the homeland of that tribe. We've got about 1,100 students and about 200 students in STEM majors. So compared to UTEP, for example, we're relatively small, but we're relatively large for a tribal college in terms of enrollment in STEM majors. We have about 65 full-time faculty with about 22 full-time faculty in STEM degree programs. And bottom line there, I've listed our four-year STEM degree programs, which are quite focused. Many of them are heavily focused on land management and land restoration type of bachelor's degree programs. We also offer a four-year degree in computer engineering and in information technology, and those two degrees in particular are where the students that I work with. So at SKC, years ago, we developed a hypothesis about how we at our institution could tackle this challenge of encouraging more Native American students in particular to go into STEM fields. And one of the roads that we've been following and plan to follow into the future is engaging with NASA and engaging with the work of NASA through NASA flight missions. So the hypothesis is that the opportunity for students to participate in those flight missions will recruit them into our STEM major programs and motivate them to complete their degree and motivate them to go on to successful careers in NASA-focused careers, which could be at a NASA center, could be at a NASA contractor, or at a university that performs NASA-funded research. And what I want to do here in the next few slides is provide some examples of how we do that and some evidence that I believe supports we're making some progress. So there's four recent examples of flight missions that SKC has participated in that I want to just briefly mention. One of them was a short experience or a week-long workshop at Walt's Flight Facility in the Rock On workshop that maybe some of you have heard of. And then a project that took about 2 years to complete, the NASA High Altitude Student Platform Program, flight number 5 SKC participated in. And then our biggest participation is in the Mars Science Lab mission, which just launched last Saturday successfully. And another rather large project that we're engaging in now is the development of a small satellite, a CubeSat, that we hope to launch by 2014. So just last weekend, on Saturday, MSL launched. That's the picture in the upper left there. And what this mission is going to do is put the next rover onto Mars. There's been 3 so far. This will be the 4th one. It's called the Curiosity rover. And what this mission is designed to do is to go to the landing site, Gale Crater, in the upper right corner, and assess whether Mars has ever been habitable for microbial life in the past or possibly in the present, and to explore this puzzle of comparative planetology between Venus, Mars, and Earth to help us also better understand Earth. So SKC's participation on this mission has started in late 2004, and it's been in participating on the science side of the mission in the development and design and ultimately the operation of 3 of the 10 science instruments that the MSL rover is carrying to Mars. And these are 3 camera systems, MARTI, MAHLI, and MASSCAM. MARTI is a camera that's bolted to the rover body that as the rover comes in for landing will take MPEG-4 video, HD video to give the science team better context of the region around the landing site to help plan out the first few months of operations on the surface. It'll also be great, a great education and public outreach video. It'll be pretty spectacular. Mastcam are 2 cameras up on the rover mast, which you can see right up in here. And these are 2 cameras that are multi-purpose. They're designed to sort of look off into the intermediate distance to help plan for where we're going to go next. But it's also got a filter capability on it to do filtered color imagery, to do some identification of the rocks that we see in rock outcrops and soils, and also to study the atmosphere and potentially water ice and frost that will form on the surface. The MOLLE camera in the lower right is a camera that's out at the end of the robot arm. It essentially takes the role of a geologist walking around with a hand lens and picking up a rock and studying the site in that manner. These 3 instruments, the principal investigators are from Malin Space Science Systems in San Diego. Mike Malin is the PI on MARTI and Mastcam, and Ken Edgett is the PI on the MOLLE cameras. So SKC's contributions to this mission to date and where we're going with this. So we began in 2005, and since that time, myself and 11 of my students have participated up to now. And that's involved assisting with the design of these cameras, the testing to get them ready and certified for flight, developing procedures and software for flight operations that will begin next summer when the rover lands. We also hosted one of our science team meetings. We have 22 science investigators, 2 PIs, and 20 co-Is that are on these 3 instruments. And this picture in the lower right here was a field trip we took last summer up to Glacier. We had one of our meetings up at SKC. Well, from now until we arrive on the surface, we'll continue with preparing and training for surface operations and planning for the science investigations. We'll land August 5th next summer, and I'll spend the first 90 days along with 4 of my students at JPL assisting with operating the cameras and performing science investigations and writing instrument papers and science publications. The prime mission goes through July of 2014. That's 1 Mars year, about 2 Earth years. But if the rover is in good health, it's very likely this will be a very long mission. It could go well beyond 2020. Another flight mission I'd like to mention is this HASP flight that I had listed back in one of the previous slides. This is a program that the NASA Balloon Program Office, together with Louisiana Space Grant and Louisiana State University, sponsor to give students experience on designing a payload, getting it ready for flight, putting it on one of these very large high-altitude balloons that you might have seen pictures of for when measurements are made of the ozone layer in Antarctica. They launch these giant balloons that go around for months around the South Pole. These are almost that size that they launch within the U.S. They launch either from Texas or from New Mexico. There's been six flights actually to date, 6 years that this program has run. Right over here is a picture of what the balloon looks like when it's being inflated. When it gets to altitude, which is about 125,000 feet, it's like 300 feet across. These are very large balloons. Hanging below is a gondola that contains radio communications, contains the science payloads that can either be rather large or they can be smaller ones that are out on these outriggers. And the SKC payload, there was actually 2 cameras that flew here last August, identical cameras that were out on those outriggers. So this was a prototype camera, a prototype design for a camera that will eventually go into our CubeSat. It's designed to be small and to be space survivable. So students from SKC, 10 students, and 2 faculty mentors, myself and a computer engineering faculty member, Thomas Trickle, were the mentors. And we started this project in December of '09 and finished with our flight on August 31st, and we're just now writing up our science data and wrapping up this project here next month. Picture up in the upper right shows one of the student leads on the project, Matthew Friedlander, who is a senior computer engineering student at SKC. It shows one of the pictures from at float at 125,000 feet. The students' cameras work great. That's looking down on the Arizona-New Mexico border. Down in the lower right there shows the flight track and launch from Fort Sumner, New Mexico, which is really out in the, I thought SKC and the Flathead Reservation was out in the middle of nowhere. This is out in the middle of nowhere. Their claim to fame is at that NASA balloon facility there. That's the town where Billy the Kid was shot. Third project is the CubeSat project that we began here earlier this year, back in January. And this will be a tribal college built, not just SKC, it will be mainly SKC students, but we also have NASA funding to bring in summer REU students from other tribal colleges. And this past summer we had a student from SIPI and a student from Stone Trout Community College, which is one of the other Montana tribal colleges. This will carry a camera, and it's primarily an education mission, but we also will be doing some hydrology and atmospheric science also from this payload as well. We completed Phase B, the preliminary design phase here, just back in October, and it went to external review in November, early in November. And we have submitted a proposal to the NASA CubeSat Launch Initiative earlier in November. And we hope to hear that we've been successful on that in late January. And we're asking NASA for a launch opportunity, which would likely be on a shuttle resupply mission, or a space station resupply mission in late 2013 or 2014. And over the life of this project, there will be 14 SKC students, 6 other tribal college students from elsewhere, and 4 faculty mentors from SKC participating in this. Picture in the lower left shows one of the SKC faculty mentors with one student that's kind of hidden behind them. They're working on the antennas for our communications ground station for communicating with satellites. And the picture in the lower right is actually the CubeSat from Montana State University, which just launched in October successfully. Just to give you an example of what these things look like. They're very small, they're about 4 inches on the side. A shorter experience was back in June of 2 students and 2 faculty mentors that went to Wallops for a week-long workshop to learn how to make payloads for flight. And then they launched a small payload, which was essentially a Geiger tube for detecting energetic charged particles from Wallops on a Carrier Orion sounding rocket. So the funding for this has come primarily from NASA, from the NASA Tribal College and Universities project program. We've got 3 years of funding that mainly funds our CubeSat project. We also have funding through the JPL MSL project funding from our science lab, and past funding has come from NSF on their TCUP program. So the last slide is just one example, back to the hypothesis I showed earlier, that having these opportunities for tribal college students to be involved with flight missions will have an impact and is having an impact. So one student I'd like to provide as evidence for that, he was actually here on Tuesday on the student panel talking about his experiences at SKC and at Johnson Space Center, is Cody Ensley, who is a senior student in our computer engineering program. He began with 2 internships on the MSL mission earlier in his academic career, and then went on to 2 internships at Johnson Space Center in the Software Robotics and Simulation Division, working on Robonaut 2, which is this kind of freaky-looking robot that's up on the space station now. Cody did excellent work down at JSC. He was commended by his division director for making a significant contribution to that mission. He was asked to come back in January of 2012, so he's going back from January through March, and he will graduate in June next summer. And he's been told by his division director to expect a job offer as a permanent JSC employee once he graduates. Thank you.